DZCB, initials for DMR Zone Channel Builder, is a code plug generator written in Python targeting DMR radios such as the TYT MD UV380, Anytone 878, and Radioddity OpenGD 77, among others. DZCB fetches frequency information from a variety of sources, most notably P&W Digital's auto-generated repeater talk group matrix, and repeater book proximity search for known repeaters within some distance to a point of interest. The analog and digital channels from multiple sources are combined and filtered according to built-in and user-specified rules. Finally, DZCB converts the generated code plug to a variety of output formats to be further modified by hand, if desired, and written to the radio. The separate but related repository example code plug leverages DZCB and GitHub actions to automatically generate code plugs in the cloud whenever the code plug source files are modified. Next, I'll demonstrate how to download a cloud-generated code plug and open it in each supported CPS. So the website is github.com/mycodeplug/example-codeplug. And this is the example repo you can fork. And the default code plugs that I build are here on the releases tab. So you can download codeplugs.zip, and that will contain a directory for each generated code plug. So in this case, I just have mine in the example, so it's my call sign. And we'll see inside here that there is a Anytone directory. So this copies over with each supported Anytone CPS version. There we go. And then there's edit CP for the Farnsworth JSON files, and finally GB3GF for the OpenGD77 CSV. We'll get that out of the way, and we'll start with the 878 as an example. So normally you would load the code plug from your radio first or from a file. We're just going to use the default here as an example. So go to Tool and Import, accept this, and select the channel CSV. So go to Desktop, select the code plug directory. We're using the 878 and channels. Do the same for zone and scan list. And finally, we'll go in and we'll select the talk groups CSV. And click import, and here we wait. So what the DZCB is doing is it goes through the repeater talk group matrix, and it generates a channel for each talk group that is on each repeater, and then puts all the channels for a given repeater into a zone. So normally this would be a manual process that you'd have to do editing a code plug, but there are a few generators available that have made this task a lot easier, and I'm hoping to make the generation process itself more accessible. So the import is just finishing up here, and then we'll cruise through and just take a quick look at what this looks like here. Import complete. Alright, so we'll start at the channel list, and we see that it's imported a bunch of analog channels from our default import files and from repeater book, and then we have some digital channels here from the P&W Digital talk group matrix. Flip over to zone. We got some zones in here. Scan lists. And under digital, we'll find the talk groups. Since this is a blank code plug, there's no ID, but if you loaded your own, that would show up in here now. So next we'll go to Farnsworth Edit CP and take a look at what the generated code plug looks like for the TYT style radios. So we'll go to File, Import, and import JSON file. And in this case, it's the edit CP subdirectory of the code plug. and the name is based on what's used in the generate script. So for Farnsworth, it is actually based on an existing JSON file. So I have downloaded the settings from my radio that I had configured before, and then uploaded those to the example code plug as a template. And each time the code plug is generated, it's going to replace the contacts, channels, zones, scan lists, and group lists, but it's going to keep all of the existing settings from the template, like my radio ID and various other configuration items. So if you were generating a code plug for yourself, you'd fork the repository and upload your own template. So let's see the channels here. This is the same configuration as the Anytone, where we have one channel per talk group with the repeater code listed as a suffix. And under zones, we have one zone per repeater and one zone per analog. And then each channel here has the repeater code suffix and a shortened talk group name to keep it readable and usable and under 16 characters. Here's the talk groups, and finally the scan lists. And the scan list is just like a zone, except you need one to scan. Here's an analog example. Alright, next we'll turn our attention to the OpenGD77 CSV. So this uses a downloaded code plug from the OpenGD77 CPS, and I already have one here that I downloaded from my radio earlier. So I'm going to open an existing code plug, and that's going to pull in my ID and other settings I already have configured. So it gives you some numbers of what you have here, and I'm going to replace all these by selecting import. I'll navigate to that GB3GF directory and OpenGD77. So once those come in, you'll see that the numbers, make sure that looks right, and finally save that code plug out to a native format. Once we get this saved, we'll open it up in the OpenGD77 CPS and take a look at it. This will open that generated code plug here, and we'll start with the channels. And the OpenGD77 is a bit different platform. We don't have to multiply the talk groups across each repeater, because the repeaters themselves will see have a talk group list associated with them already. And the talk groups on the OpenGD77 have a time slot associated with them. So when we do it this way, we don't have to create a channel for each talk group on the repeater. We just create one channel per repeater, and then have a talk group list associated with that repeater that specifies the static talk groups. And here's that contact list. And there's my DMR ID, because this was based on an existing code plug, and that's it.